Hi students, good evening to everyone. Happy Holi to all of you. So today's session, fluid mechanics, and we are going to look at some of the very interesting questions on your fluid mechanics. All right. Now, properties of liquids I'm going to do in a next session or some other session, let's say. All right. But today we are going to deal with your fluid mechanics. All right, so let's get started right away with the session. Now, before everything else, those who are watching me live for the first time on the JEE English channel, my name is Sumit Kundu. I am a BTech graduate from IIT Bombay, and in the year 2003, that's when I cracked IIT JEE, and my rank was 2125. All right, so I got civil engineering. And 4 years, that is 2007, I passed out, and after that I took up a job of a software engineer, and 4 years I was into the corporate sector. And since 2010 I have been teaching, I have been mentoring, coaching, and lots of students through these years, guiding them through their journey to achieve their goals and dreams to get into a prestigious college in this country. So that's my introduction, students. So anyways, sir, please upload more trucks. By the way, good evening Yash, good evening Sumit. All right, so let's move on to the next slide. Now here in this slide, let me talk to you about the tinyurl.com/JEE mobile. Now this is a URL which will give you access to all the lectures that has been conducted over the past year for both 11th and 12th standard for physics, chemistry and mathematics. All right, so if you missed out on anything, you know what to do. Just go on to this URL and you will get all your lectures. That is also for free. All right, now moving on to the next thing, students, if you haven't taken the subscription of your Plus, that is the Plus subscription of Unacademy, go ahead, get it and use the code SMLIVE. Use the code SMLIVE and right away get a 10% discount. Students, remember that right now special prices have been designed, that is instead of 36,000 for 24 months, that is for entire 2 years, only 36,000. Now the prices have slashed down to 32,400, and on top of that you're getting a 10% discount on using the code SMLIVE. Okay, so let's get started off with our today's session. Hi smart boy Vishal, hi Sumit Singh, hi Bhaskar, and hi everyone. Okay, chalo, let's have a look at our first question. Now what is my first question telling me? Let me just have a look at this. So let's get started here. We have a vessel, okay. Height of the vessel, like height of the water column in the vessel is actually 2h. How much is it? 2h. It is standing on a platform. It is standing on a platform which is a height of h, right? Water is coming out of this from a hole, So you guys can also start attempting the question. Now the hole is located at a distance of x. Okay, it is located at a distance of x from the base. It is at a height of x. Now water is coming out of it. Now it will be falling at a certain distance. We'll call it as the range. We'll call it as what? The range, right? Now they have asked us what should be the distance x from the ground so that the range is maximum. All right, so do I have any answers coming up from your end, students? PK Mishra, Sonu, Unique, Girmi, yes, hi, hello, good evening to all of you. Okay, so let me see if you have already solved the question. Well, let's move ahead. Let's look at the solution to this particular problem. What do we have here? Now see, how much time is the water going to take in order to come down? See, it is a simple projectile motion kind of a problem. Okay, it is a simple projectile motion kind of a problem. So if the water has to come and drop at this location here, okay, what will be the range? Range will be equal to the velocity with which it is actually coming out, because initially as the water comes out, it has only horizontal component of velocity, right? It has only horizontal component of velocity. So that velocity is not going to change because there is no force in that direction, all right? So that velocity is going to remain fixed, right? Second thing is, let's say it takes time t in order to cover this vertical distance x. It takes time t in order to cover this vertical distance x, right? So the range will be v into t. Now what we will do? Simple. We will go ahead and find out your v and t. We will go ahead and find out what? Your v and t. Simple. Now v is equal to root over 2g into height of the water column above that particular hole, isn't it? Height of the water column above that particular hole. Now this entire distance from this position to this position will be 2h plus h, that will be equal to 3h, and the hole is x distance above. So this height will be equal to 3h minus x. So it will be equal to 3h minus x, right? So this is the velocity, right? Now in order to cover this height x, we will take the kinematic equation x is equals to half into g into t square. So I will get the value of t as equal to twice x upon g into root, isn't it? Simple calculation. Right? Now, what do I have here? No, Sonu, the answer is not going to be B. Let's have a look at it. Okay, what will be the answer? So, we'll go on to the next page. We'll write down the range as equal to V into T. So, V came out to be equals to 2G into 3H minus X, and T was equal to how much? Root of twice X upon G. So, I can write it as twice X upon G. So, G and G will cancel. So, we will get root of 4 times 3hx minus x square. All right. So, this will be your range. Fine enough. Now what you do is you square up both sides of the equation. You will get range square will be equal to 4 times 3hx minus x square. Take derivative. Now we know the range. They have asked us the condition, the value of x for maximum range, right? So for maximum range, what we do? I mean, it's a general procedure, isn't it? You take the derivative of the range with respect to x. So you get 2r dr by dx will be equal to 4 times 3h minus twice x. Fine. Equate this entire thing to 0 because we equate dr by dx to 0. When I equate this entire thing to 0, I will get 3h will be equal to 2x, which implies the value of x will be 3 divided by 2 into h. I hope everybody has got the right answer. Option C would be the right answer. All right. So it was a little lengthy, but yes, all the concepts cleared for the velocity of efflux if you dig a hole into a liquid column at a certain height. Is the concept clear, everyone, students? Fine. So what happens with your hand? Simple thing. I think it's very easy to guess, Anand, right? It was Holi and I did play Holi. So that's the thing which happened with my hand. By the way, I hope everyone else has also enjoyed today's day. Okay. A little bit of studies, little bit of fun. Yes, that's a perfect recipe for life, isn't it? Chalo, let's have a look at the next question. Next question is like very, very interesting. Okay. So usually my first question is a warm-up question, right? So the first question was indeed a warm-up question, and now we kind of move on to a more challenging problem. Okay. Now what is the problem here? I've got a vessel in which it is filled up with liquid. Now I start moving it with an acceleration of a. Then they have asked us that what should be the value of the acceleration such that this extreme point here will have a pressure equal to the atmospheric pressure. This will have atmospheric pressure. All right. So how do you go about this problem? See, when you accelerate, so do I have answers coming up? Do I have answers coming up from your end? Okay, chalo, let's go ahead and discuss this problem. Fine enough. See, whenever a fluid is being accelerated, the surface of the liquid becomes slant, right? So, let's say the surface of the liquid became like this. Now, the point is that this point A will have atmospheric pressure, all right, only if this point is just very close to the surface. If it is very close to the surface, let me redraw the diagram for you once again for a better understanding, isn't it? So let me say that this is my vessel out here and I am considering some point, let's say out here, extreme end. Fine enough. Then what is going to happen when you accelerate it? When you accelerate it, the liquid level is going to have this kind of a shape, right? So I am talking about this point here, and this should have what? Atmospheric pressure. If it is supposed to have atmospheric pressure, this point will lie just above the water surface, because if it is below the water surface, atmospheric pressure plus the pressure of the liquid column will be added up, isn't it? So it will not be having just the atmospheric pressure. So in order that this point has got atmospheric pressure, it will be just lying above the surface of the water. That means the liquid will try to slant in such a way that it will come up to this end out here. This point is very much clear to everyone? This point is very much clear to everyone? Okay. Now, let's move ahead. Acceleration is equal to A. Acceleration is equal to A. Definitely, if this was at a height of 2 meters, it must have actually gone up, isn't it? I mean, if I look at this diagram, what would actually have happened is this level of water would have actually gone up. Definitely, if it is going down here, it has to go up in the other direction, isn't it? Now, the volume of the liquid inside this vessel is going to be constant. Nothing but 2 into 3 into the depth. So, the depth, let's say, is equal to D. Now, here in this case, the second case, when I write it as, let's say, O, X and Y, then this will have the volume V1 as equal to half into base, that is 3, into height. So this height has now changed. So this has become H. So this is equal to H, right? Now, what are we trying to do here? Very simple. Okay. See, the acceleration is equal to how much? There is a simple formula, that is A should be equals to G tan theta, where theta is the angle that this liquid surface is making with the horizontal. Theta is the angle that the liquid surface is making with the horizontal. So acceleration should be equals to G tan theta, right? Now, if we get the value of H, we can find out the value of tan theta. That's simple. Okay, so if I equate V to V1, what will we get? We will get something around, let's just equate V to V1, we'll get 2 into 3 into D will be equal to half into 3 into H. So 3 and 3 will cancel, and obviously you need to multiply a D out here for the depth. So into D. Now D and D will also cancel, which implies H will be equals to 4. H will be equal to how much? 4 meters, right? So we can find out the value of A to be equals to G tan theta. Tan theta will be how much? 4 divided by 3. 4 divided by 3. So simple. I think acceleration we found out, it will be 4G divided by 3. Simple enough. 4G divided by 3. That's the answer, option B. Very good. Anudeep Reddy, Romeo. Guys, I think you should use your real names. I mean, I think it's the real name. Romeo, Romi, Prashuraj. Guys, all have done it superb. Okay. Dropper batch, when will it start? It will start in the month of April, students. It will start in the month of April. Okay, so you need to hold on with some patience right now. Okay, now let's move ahead. I hope everybody has understood this. Let's move ahead to the next question. Now the next question is also very interesting. Okay, next question is also very interesting. I have got three cases, three scenarios. Okay, the first scenario, have a look at this. Simple. There is a block of mass m. Okay, now all these balls are pretty much alike. They are identical. All right, what is it? That they are identical. In the first case, it's partially submerged and partially in air. In the second case, it is like fully immersed, but it is floating. In the third case, it actually sinks to the bottom surface. All right, now in the three cases, they have asked us to compare the forces exerted on the base of the container. They have asked us to compare the forces at the base of the container. Like, you know, this here is FA, this here is FB, and this here is FC. Okay, sorry, FC. So we need to compare. The question is very much cleared. Let me have the likes coming up. Let me have the likes coming up to just understand how many students are currently active in the class. Okay, so I see 23 people are actually active in the class out here. Yes, 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 go ahead, fine. So I hope everybody has understood what is the question. Case 1, case 2, case 3. Case 1, partially submerged, partially immersed. Case 2, fully submerged but floating. Third case, to the surface. Okay, simple enough. Okay, now let's go ahead and analyze these cases. By the way, do I have answers coming up from your end? Rishi, that's correct answer, and no, Asha, no, that's well, B and D, they are the same, but they are anyways not the answer. Option A is the correct answer. FA is equals to FB equals to FC. Fine, good enough. Okay, but how did we get it? How did we get it? If it is a fluke, well, God help you, but let me try and understand. Let me try to explain it to you. How is the working out here? Okay. Now in the first case, this will experience a buoyant force in the upward direction. We'll call it as your FB, and it will be experiencing the gravitational force that will be equals to mg. Okay. Now I know for sure that the force which will be exerted on the base, let's try and understand this very clearly. Okay, there have been some similar questions in your JEE mains in the past from similar concept. Okay, so let's say this force is FA. On the ball, if I take the subject as the ball, then this ball is balanced. The forces on it is balanced. It is in equilibrium. So your FB will be equal to mg. Very simple. All right. Now, what will be FA? Try and understand. The buoyant force was exerted by the liquid on the ball in the upward direction. Now, by Newton's third law, a similar force will be exerted by the ball on the water. Now, this force is going to transmit through the liquid and act on the base of the beaker, whatever beaker that we have this into. So, FA will be equal to the buoyant force, right? So FA will be equal to FB, that will be equal to mg. Simple enough. All right, fine enough, students. Okay, now in the second case, if you look at the second case, here also if you see, there is FB and there is mg. Clear? And there will be a force on the bottom surface. There will be a force on the bottom surface. Now here also we can understand that FB will be equals to FB, that is a buoyant force, and FB will be equal to mg, so this will also be equal to mg. Clear enough? So one thing is very clear, FA is equals to FB. This is clear, but this option is also there. All right, that is FA is equals to FB, option C, which is also present. All right, now let me try to analyze the third case, which is a little bit of a challenge, but I am sure it's not going to be very scary. All right, now here in this case, if you look at this diagram out here, if I take only the ball as the system, then what are the forces acting upon it? Normal force in the upward direction, buoyant force in the upward direction, and mg in the downward direction. So I can write here that my FB plus normal will be equal to mg, right? FB plus normal will be equal to mg. Now if you look at the base, what are the forces acting on the base of the container? It will be equal to FC plus, if this ball is being exerted by a force of normal reaction in the upward direction, the same normal reaction will be in the downward direction. So this will be FC plus another force, that will be normal. So the net force will be FC plus normal. Okay, it will be equal to what? FC plus normal. Now we can see here, if you calculate these equations, very simple, right? See, FC is in the downward direction, we need to calculate FC, right? We also have the normal force acting in the downward direction. We also figured out that FB plus normal will be equals to mg. So here also, if you calculate, your FC will come out to be equal to mg, as a result of which option A will be the correct answer. I hope everybody has got the right answer out here. That is, option A is the correct answer. Okay, so students, let's move ahead to the next question. All right, chalo, let's move ahead to the next question. What do we have in the next question? Let's see this. Okay, we've got a U-tube. Fine. Now in this case, what happens is, let's say the entire U-tube is moved towards the right with an acceleration of how much? With an acceleration of A. It is moved towards the right with an acceleration of A. So there is a pressure difference corresponding to a height of h. The water level rises up. Initially, if you see, the water level was the same in both the U-tubes. But when it started accelerating, right? What happened? The water level rose. Fine enough. Now the question is, okay, then what will be the value of h? That is, when at rest, a liquid stands at the same level in the tubes as shown in the figure, but as indicated at height difference, h occurs when the system is given an acceleration of A towards the right, then what shall be the value of this h? So this is what we need to find out. Fine enough. Okay, now students, try and understand that if it is going with an acceleration of A, then every point of the water is also going with the same acceleration A. Every point of the water on the bottom surface is going with an acceleration of A. If I take this entire liquid column, on the horizontal limb, everyone is going with the same acceleration, right? Now try and understand that this point here will have a pressure P1, and this end will have a pressure, let's say, equal to P2, right? So the net force acting on the bottom column of water, that is in the horizontal column of water, will be equal to the net force P net will be P1 minus P2 into A. What is A? A is the area of cross section of this particular portion. Area of cross section, that is A. Fine enough. So that is the net force that will be acting out here. Well, let us see. People are giving the answers as option D. So we will find it out. Fine. So this is the net force. Now what is the difference of pressure between this point and this point? Between P1 and P2, what is the difference of pressure? It is equal to what? Rho GH. This difference in pressure is equal to rho GH into A, right? I hope this point is very much clear. Okay. Now, what will be the difference of pressure out here? This thing. It will be equal to nothing but from the horizontal limb, if you see, it will be equal to rho, acceleration will be A into G. Fine enough. If you see, this is equal to the net, all right, rho A into G, right? So if I calculate F net as equals to rho GH into A. By the way, no, this is not what we are trying to get here. Simple enough, we don't need to calculate this, okay. What we can simply do is, this will be equal to mass times the acceleration. Now what is the net mass of the liquid in this particular column? The net mass will be equal to its volume, that will be volume into density into acceleration. Now what is the volume? Volume is the area of cross section into L. So this will be equal to area of cross section into L into rho into A. Now we will go ahead and equate this A, L, rho into A. A and A will cancel, rho and rho will cancel. So acceleration will be how much? GH upon L. So we can see here GH, well, there is some error. Okay, we need to find out H. So H will be equals to AL upon G. That is the correct answer. I hope you understand that. Okay. So yes, option D is the correct answer out here. Fine students, I hope everyone has done the question at your end as well. That is superb, good show. Okay, let's move ahead to the next question. What do we have here? This is a very interesting question. Chalo, one really very good question for today's session. What do we have here? Let's see how many of you are already working on this. Now let me just go ahead and discuss. What is here? We've got a number of cylinders. And on top of it there is a plank. On top of this there is a plank, right? Now on the plank of the cylinders, we have got a L-shaped tube. Right? It is filled up with some liquid. Inside this L-shaped tube. What will be the acceleration? In the forward direction, so that liquid does not come out either from this end or from this end of the tube. Is the question clear to everyone? Okay. That is, what should be the acceleration of these cylinders so that the liquid will not come either from the vertical column or from the horizontal column? Very simple. Okay. How do we approach it? Now, one important concept of rotational mechanics that we need to apply here, that is for any rigid body, if it is lying or it is having pure rolling. Now, important point is there is no sliding taking place. So if there is no sliding taking place, all right, that means it is pure rolling. Now in case of pure rolling, if the center of mass is moving ahead with an acceleration of A, then the topmost point will be moving ahead with an acceleration of how much? 2A. So this is the concept we need to use from the rotational mechanics. Now that's pretty simple. Okay. Now how do we go about it? Try and see. See, if there is no liquid coming out either from this end or from this end, all right, that means the pressure at point A, we will try to calculate it. Okay, the pressure at point A, see, mostly liquid will not come out from here, that is for sure. Liquid may tend to come out from here, but what we will try to see is that the pressure difference is such that this is P ATM and this is P ATM. We'll try to calculate it. Okay, so this point A, we will try to see that it has a pressure, let's say, equal to PA. Now from the vertical column, from the vertical column, what will be the pressure at A? It will be equals to P ATM plus rho G H, right? The pressure at point A will be equals to P ATM, it is open to the atmosphere, plus rho G H, right? Now from the horizontal column, we know as we keep going in this particular direction, okay, in the direction of the acceleration. Now here, what is going to happen? What is going to happen? The pressure is going to increase, right? So what is it that we will try to calculate here? From this, we will see that PA will be equal to P ATM plus rho into 2A, and the distance is equal to L, right? So from both this, we can see that rho GH will be equals to rho into 2A into L. So rho and rho will cancel. We will, what do we need to find out here, by the way? What will be the value of acceleration? So acceleration will be equal to GH upon 2 times L. GH upon 2 times L. So we have option A as the correct answer. Let's see how many of you have got it correct in the session. Rishi Joshi, Mansi Kapol. So that is awesome. Pushki, that's great. That's great. So a lot of you have actually got this question correct. This is awesome, guys. It is awesome. Okay. Now let's move ahead to the next question. Next question. Now this is pretty interesting. So what do we have here? We have a beaker, we have a container which is completely filled up with water. Okay, we have a container which is completely filled up with water. At the bottom level, they have made a hole. At the bottom level, they have made a hole. Okay, so water is coming out with a velocity of V naught. Water is coming out with a velocity of V naught. All right. Now, what do you do is, when water is coming out, so definitely the level of water is going to go down, 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 down. When the water was like half filled, when the container was like half filled, you tilted it by 45 degrees, okay, so that the hole came right at the bottom out here. Then what shall be the velocity with which the water is supposed to come out of this hole, right? We need to figure out what will be the velocity with which the water will be coming out through this particular hole. So how do we solve this particular problem? See, the velocity of efflux, remember, totally depends on the height of the water column, all right, the height of the water column above that particular hole. Now, we know that this height was initially equals to h. Now, I'll take it as, let's say, h1. So, the velocity of efflux will be root over 2g into h1, 2g into h1. Now, in this triangle, if you see, I dropped a perpendicular from here to this particular point. Okay. Now, this h1 will be nothing but, now this angle is, let's say, theta. We know theta is equal to 45 degree. So, your h1 will be equals to h sine 45 degree. So your h by root 2 will be the value. So velocity of efflux will be 2g into h divided by root 2. So I can calculate this as equal to root over 2gh divided by 2, I mean to the power 1 by 4. That is the 1 by 4th power of 2. Okay. Now what is 2gh? Root over 2gh. In the first case, the height was h. So the velocity V naught was equal to root over 2gh. So I can write this as V naught divided by 4th root of 2. Alright. So which option does match with this? It is actually option D, which is the correct answer. You guys are awesome out here. Well, option C is not the correct answer. Romeo, yes, that's correct. Ashutosh Chauhan, that's correct. Yes. So I hope, students, you are enjoying the questions in today's session. It is pretty refreshing, all right. And the questions are definitely your JEE mains level. If you are getting a hang of these questions, if you have been able to understand these questions, let me tell you, you should be very confident about the fluid mechanics part. Okay, that is all the accelerated fluid. Okay, I think a lot of you have done most of the questions related to the accelerated fluids. Now, accelerated fluids happen to be one of the challenging areas. I mean, we have not taken for today the rotating fluids, right? When the fluid is rotating with an angular acceleration of omega. Okay, we have not taken that, but I would suggest that you revise that part also very seriously. Okay, so these are the part where the challenging problems come. Okay, by the way, rest of the other parts of fluid mechanics happens to be like very easy. They are like formula based. Okay, so there is little bit of an imagination which is required for this part. By the way, everything else is not very challenging. Most of the questions would be your formula based, other than the accelerated fluids part. Okay, now let us look at some more challenging problems. Like this one was pretty easy, so let's skip that. Okay, and let's go to this one. Now we have got a block here. It is connected to two springs, spring number 1, spring number 2. Okay, both have a spring constant of K. All right, both have a spring constant of K. Initially, when it is equilibrium state, then this block here is just touching the surface of the liquid, out here. Okay, this liquid has got a density, all right, 2 sigma, and the block has got a density of sigma, and the liquid has a density of 2 times of sigma. All right, now a weight is placed on the block, so there is a small weight which I will go ahead and place it on this particular block. Then what is going to happen is, this block initially present, which has got a value sigma, okay, the density is sigma, it is going to be half immersed into the liquid. The question that is asked is, what will be the value of this weight out here? Let me take it as your W naught. All right, is the question clear to everyone? Okay, all right, let us go ahead and answer to this question. Fine, looks challenging. We have some even more advanced level of questions associated with this. If I remove that weight, okay, is it going to execute an SHM? If it does execute an SHM, then what will be the time period? Well, we will discuss about that later. Let's now only focus on this small block which has got a weight W naught, okay, and which has been able to bring this bigger block down by A by 2. That is 50%, it is immersed. This is a cubical block. So it has got an edge length of A, and A. Fine enough. Okay. So we will write down our equations first. Now, if you get the equations correctly, problem is not very difficult. Only you need to visualize it in a much clear way. Okay. So in the first case, when I have not placed this block, let's say the block is out of the picture. There is no block on it at all. So we are looking at the first equilibrium point. Okay. Now at the equilibrium, this base is just at the surface. So in the first equilibrium point, no buoyant force is going to be there on the picture. It is only the spring force. And the weight of the block. Okay, so let's say this block has got a weight of W. So I can say W minus, now why minus? W will be acting in the downward. Listen to it very carefully. Stepwise we will go, you will be able to understand. Very simple. Okay, weight is in the downward direction. If weight is acting in the downward direction, it must have pulled the spring downward, the upper spring extension, the lower spring compression by X. Let's say in the equilibrium position, this block moved down by a distance x, and by moving by a distance x, it has just touched the surface of the liquid. It has just touched the surface of the liquid. Okay, so that got compressed by x, that got elongated by x, so 2kx is the net spring force, and this should be equal to 0. All right, till here it is clear. Till here it is clear, everyone? Okay, awesome, awesome. Now you go ahead and place the block on top of it. Let's say that is W naught. That is W naught. Okay, now W plus W naught, that is the net force acting in the downward direction. Now second scenario in which the block has moved down 50% down, 50% it has moved down. Okay, very good. अरे लिखो तो भैया कहाँ चले गए? Now this is moved down by a by 2. What is happening? A by 2. All right, so now what is going to happen? Besides the weight and the spring force, the buoyant force will also come into the picture. Okay, so how much will be the spring force? The weight is W plus W naught acting in the downward direction. Spring force will still act in the upward direction. So how much will be the spring force? Minus 2 times K x plus A by 2. Simple, because it has gone down. So total extension is x plus A by 2. X was the equilibrium extension and elongation. Acha. Minus. Why minus? Because buoyant force will also act in the upward direction. So how much will be the buoyant force here? Try and understand. Volume of the liquid displaced into density of the liquid into G. So volume of the liquid displaced will be A square into A divided by 2 into 2 rho into G. This should be equals to what? 0. New equilibrium position, right? Why 2 sigma? Because the density of the liquid is 2 sigma into G is equal to 0. Simple enough. Okay, now let us calculate. Let's calculate from these two equations. Now how do we go about it? W is equals to 2kx. Very good. So this is going to be W plus W naught minus 2kx minus 2k A by 2 minus A cube. 2 will cancel, sigma into G will be equal to 0. So I can clearly see W and 2kx will cancel out, which implies the value of W naught will be equal to 2. Achha, 2 will cancel, 2 will cancel, so life will become simple. If life becomes simple, then we can easily calculate. Okay, so this will be equal to Ka plus sigma A cube into G, and that will be your answer. Which one matches? Which one matches? I think it is option B, which matches with the correct answer. Very good, Abhi Ashutosh Chauhan. You have done it very, very correctly. All right. Chalo, I hope everybody has understood this question, right? Now, students, if you take away this block, food for thought for all you students, that is there going to be an SHM, and if there is an SHM, then what will be the time period of this particular SHM? Leave it as a homework for all you students. Okay, chalo, now let's go ahead and discuss the next question. Okay, what do we have in the next question? Now this is a little challenging, okay, but it is solvable. It's not very difficult. Okay, what is it? I see a pulley, and I see a container where block B is immersed. Okay, where block B is immersed. Now block A is something that we have here, and block B is something we have here. Okay, now block B has got a mass of 3m. This has got a mass of 3m. Fine enough. Block B has a mass of how much? 3m, and the density of the block is 2 times rho. Density of the block, this block is 2 times rho. 2 times rho. Fine enough. Very good. Okay. The system is released from rest. Achha, I'll tell you. See, when it is inside the block, okay, when it is inside the block actually moves up. When it is outside in the air, then the block moves down. All right. Simple enough. Did you understand? When it is inside this liquid, it actually goes up. Why? Because there is upthrust also acting, so it tends to become lighter and then it kind of moves up. But when it is actually in air, it is heavier than A, so it kind of moves in the downward direction. Okay, so what do we need to find out? We need to find out what is the mass of block A. What is the mass of block A? All right, so we will go ahead and try to understand it. Okay, chalo. Now here in the first scenario, what is happening? In the first scenario, we see that it is actually moving in the upward direction. Okay, so if it is moving in the upward direction, okay, what we can take it as the net force acting on this. See, the net force would be mass of A. Mass, though this is what? This is the unbalanced force. All right. So mass of A into G, that is the force acting on this in the downward direction. In the upward direction, we only take the net. So acceleration, what is we are trying to find out is the acceleration of B. Okay. So let me take it as A1. MAG minus how much should we take? This is equal to 3m minus the upthrust, okay, into G, minus the upthrust divided by the total mass of the system, right? That's how we find out what? Acceleration, isn't it? So the net acceleration will be MAG minus 3mg minus the upthrust divided by the total mass of the system, that will be 3m plus ma. Simple enough. Now, what will be the upthrust equal to? See, one thing is very clear, that the density of the liquid is rho. Listen to it very carefully. Density of the liquid is rho and the density of this block is 2 times rho, right? So upthrust will be equal to volume of the liquid displaced, that will be equal to 3m divided by the density of this block, that is 2 times rho. This will give you the volume into density of the liquid. Density of the liquid is rho into G. So rho and rho is going to cancel. You are going to get 3mg divided by 2. 3mg divided by 2. Okay. So this is an important relationship. Okay, chalo, let's go ahead to the next slide and try to calculate your A1. A1 is what? A1 is the acceleration with which it is going up when it is inside the liquid. A1 is the acceleration with which it is going up when it is inside the liquid. And A1 comes out to be how much? A1 comes out to be MAG minus 3mg minus 3 divided by 2mg divided by the total mass of the system, that is ma plus 3 times m. How much will this be equal to? I'll write it as MAG minus 3 to the 6. 6 minus 3 is 3, right? So this will be equal to 3 divided by 2mg. Fine enough. Acha. This is the first case. This is the first case or the first scenario. Try and understand, students. This is the first case or the first scenario. Second scenario is what? Second scenario is when you take away the liquid and it is in air. This entire system is in air. Then what is going to happen is this B is going to go down with the same acceleration. So B is going to go down. Let's say the acceleration is equal to how much? A2. So A2 can be written as what? It will be written as 3mg minus simply ma into G divided by the total mass of the system, right? That will be ma plus 3m. Fine enough. But we know what? A1 is equal to A2. We know what? A1 is equal to A2. If A1 is equal to A2, I can write MA into G minus 3 by 2 mg will be equals to 3mg minus MA into G. Now, the climax comes. Okay. Simple equation. Simple equation. What will we get? 2 MAG will get 2 times MAG as equal to how much? 3 plus 3 by 2 mg. So that will become equal to 2 3s are 6 plus 3 is 9. So 9 times mg your G and G will cancel, divided by 2, by the way, divided by 2, 9 mg by 2. So MA will be equal to 9m divided by 4. I hope everybody understood it. 9m divided by 4. Option D is the correct answer. I hope students you enjoyed all the questions for today's session. All right, that's the end of our today's session, by the way. Next question was interesting. You can do it. You will get the PDF. Okay, so you can do it for your homework. So let me take it for your homework question. Okay, we need to calculate, we need to compare the density of block B and that of the liquid. Okay, you will be able to do it, I'm sure. Okay, what happens is they are saying that initially you kept this, L was the distance, it was submerged. You push that block B, it fell into the water. Okay, you push that block B, it fell into the water. Now what is going to happen is this L will decrease, H increases. Okay, if this is the condition, then you need to compare the density of block B with that of the liquid. You will be able to do it looking at the options. Okay, chalo, now important things, what is it? Students, we need to interact more and more so that we get to understand your problem areas, your pain areas as much as possible, and that's going to happen through the Telegram. So download the Telegram app, okay, and join the group. So I explained to you in yesterday's session also, it's like, you know, not just interacting with us, but you will get to find out a lot of aspirants who are a part of this group. Okay, so you get to interact with them. So if you have a doubt, post it out there. Somebody or the other will definitely respond back to your queries. All right, so that's the reason why this group is important. Okay, teachers are also active in that group. So if a teacher is looking at your problem or your queries, they are also going to answer to that. Okay, awesome. Shivendra, all right, I'm so happy to see all your happy faces and love and care and affection. And students, if you have queries, why don't, like, you know, I read the comments that you put on the comments below. Okay, so if you have anything in your mind, do not forget to put down comments on the section below out there. Okay, that is very important. Now, I told you in the beginning of the class also that tinyurl.com/JEE mobile has an archive of all the video lectures that has happened in the last year. Hi Sarthak, thanks for all the love. tinyurl.com/JEE mobile, you will find out all the lectures. Okay, so, and that too for free. Okay, that's important point. That too for free. But then what is chargeable? Well, not chargeable, rather. Let's say what is the most important thing that we are giving. So why is it called plus? Try and understand. Because it is like all the free lectures. Now here comes the plus. All right. Now in the plus you get to have a live interaction. So those are all recorded videos. Like they were live last year, but now they have come into the recorded zone. But if you want to enjoy and interact while learning and have a doubt, whatever is being taught, that's where the plus comes into the picture. So you've got live classes where you can interact directly with the educator. Besides that, these live polls and leaderboard make it very, very interesting. The entire concept of teaching and learning has changed because of this live polls and leaderboard. Students, try and understand. I'll tell you, for all the people who are active right now and who will also be watching this video later down the line, okay, what as a teacher I faced a problem throughout my teaching career is that I would teach on a whiteboard. Beside, like, you know, before all these digital thing came out into the picture, all right, I would teach on a whiteboard. I would know, like, people would all be looking at me. People will all be looking at me, but I couldn't read their mind who is understanding what in the class. Right? So they'll all be looking at me and I would know, like, oh, these students of mine, they are paying so much of attention to whatever I am teaching, so much of respect given to me. And then when we would take a test on that particular chapter, let's say we were teaching simple harmonic motion and we took a test on simple harmonic motion, okay, results would be disastrous at times, and at times few people would always be performing well, okay, but the average of the class will be not as per the expectation of the teacher. And then when you ask them what happened, so we did not understand. Okay, we did not understand. So will you explain the concept to us once again? See, that's where the teacher is able to find out the gap while teaching in the class through the live polls and the leaderboard. See, if 80% of the people answers to whatever question that you ask, and independently everyone is sitting at different parts of the country, all right, that means whatever concept you have taught, everybody is understood. Simple. You ask a simple yes no kind of a question. 80% says we have understood, let's go ahead. 80% says we did not understand, let's stay here, let's explain the concept again, and then let's move ahead. See, this is how plus will make a difference in your learning and in our teaching. Try and understand this. Okay, chalo, test series and analysis, superb thing. Okay, this need not be explained. I mean, like, it's pretty self-explanatory. Okay, chalo, important thing is live doubt clearing sessions. Okay, now while you are in a lecture, yes, there are doubts that are being cleared, but even there are special doubt clearing sessions which are being held, and you can be a part of it and upload your doubts and get your doubts clear. One subscription and so many educators that you have access to. Okay, that's like a university, isn't it? So students, needn't tell you, I'm going to just tell you the process right now. You guys are smart, modern generation, tech savvy kids, but let me just help you around with how to get this plus subscription. Okay, you get this Unacademy learning app. Just type for it, go install it. Okay, go install it, and once you have installed it, select for plus, go for plus, and then select IIT JEE, click on get subscription. Once you click on get subscription, use the code SMLIVE, and right now there are special discounts going on. Usually it is 36,000 for 24 months, but right now due to the examination season, okay, we have 32,400 as the price right now for 2 years. You can get it for 27,000 if you use the code SMLIVE. Okay, remember students, it's not just a 2-year subscription. You can take as per your needs. You can take a 1 month, 3 months, 6 months, 12 months, 24 months. Multiple options are there. Okay, so you can go ahead and check it out. Subscribe to the channel if you're here for the first time. Second thing, do not forget to press on the bell icon, because once you press on the bell icon, you will be notified of all the important lectures coming up on this particular JEE English channel, and you will get all the PDF notes. All right, whatever has been taught in today's session, you will get a PDF notes out there. Okay, so chalo students, now another important thing is, besides this JEE English channel, we have all the other sister channels, that is your NEET channel, JEE channel, foundation channel. So go ahead, spread the news as much as possible. Let everybody study on this platform for free, all right, and get also the plus subscription at the same time. Okay, and students, last but not the least important point, but the most important point, use the code SMLIVE and right away get a discount of 10%. Okay, so with that, God bless you all and enjoy. Happy Holi once again to all of you. Okay, have fun and study very hard. Okay, and have fun at equal amount as well. Okay, so maintain a balance and do well in your lives. Thank you and God bless you.